Hi students, in today's video, I am going to discuss about the spherical coordinate system, that is also known as the r theta phi coordinate system. You remember that at the starting of the coordinate system, I defined the positional vector, right? I am showing the positional vector again. See, this was our positional vector, which was denoted by AP, and the parameters of this position vector AP was U, V, and W. And by assigning some other values in these parameters, we have discussed the Cartesian coordinate system as well as cylindrical coordinate system. That means in the case of the Cartesian coordinate system, we assign u, v, w as x, y, z, as you can see over here. In case of cylindrical coordinate system, we assign u, v, w as a rho phi z, that is shown over here. U, v, w is nothing but the rho phi z. And in case of the spherical coordinate system, we assign the u, v, w as r, theta, and phi. Okay, so let me write this first. So the positional vector coordinates or the parameters of the positional generalized positional vector AP, that is the UVW, UVW, that has been denoted by r, theta, and phi respectively. Okay, that has been denoted by the r, theta, and phi. Now this r theta phi is the same r theta phi or same parameters that has been written in the bracket over here. You can see in the bracket I have written the r theta phi, that is here. Okay. Now as UVW or the parameters has been denoted by the r theta phi, then we can also write the positional vector here. Now what is the positional vector AP? AP is nothing but it is a positional vector in the three-dimensional vector space. Similarly, three-dimensional vector space means it must have the three elements along in the three directions r, theta, and phi. So that's what I am writing over here, that it has a component AR in the direction of r, plus it has also a component of A theta in the direction of theta, okay, and it has also a component of A phi in the direction of phi. So this is the positional vector actually, and not only that, it is a positional vector in spherical coordinate system. Important one. Okay. In case of the spherical coordinate system, it is a positional vector. Now, before discussing spherical coordinate system or before discussing about the positional vector more, let me draw the spherical coordinate system first. Now, how this spherical coordinate system looks like? Just a minute. Let me draw this spherical coordinate system over here. Okay. Yeah. Okay. This is the spherical coordinate system. Don't worry, I will make you understand each and every point. First of all, let us see what are the coordinates. This is the x, this is the y, and this is the z. This is the x, y, z. See, in this three-dimensional vector space, you can see there is a sphere, and outside of the sphere is actually dotted here so that you can understand it is a sphere. And as we are deriving everything in the positive x, y, and z direction, that's why from the whole sphere I have cut this portion which has been shown here by the blue color. Okay, I have cut this portion from this sphere. That is nothing but, this portion is nothing but the 1/8. I can write over here. This is what? 1/8 of sphere. This is the 1/8 of the whole sphere. Okay, just a minute. Means actually, if you uh, divide a whole sphere into equal 8 sections, then a single section has been shown over here. Okay. Because as we are considering positive x, y, and z direction in case of the derivations, right? So that's why I have considered this portion. Now consider a point P. Say this is a point P. If the point P lies over here, which has been shown here by the green color, now the distance, just a minute, the distance between the origin and the point P, this distance, okay, this is nothing but r, that is the r of r theta phi. This is what? This is the r. Okay. Now, if it is the r, then what is the theta and what is the phi? Let me show you. This is the r. That is the distance between this origin. This is the actually origin 0, 0, 0. This is the origin to this point P. Okay. Now, the angle produced by this r or the point P with respect to this z axis, that is this angle. This angle is nothing but called the theta. Okay, this is nothing but the theta. Means I can also write this is the theta is equal to 0 degree and this is the theta is equal to 90 degree. Okay, means actually the theta is increasing in this direction. Theta is increasing in this direction, like this. In this direction actually theta increases. So that's why what is the theta? Theta is nothing but the angle produced by the point P with respect to the z axis. Okay. Now what is the phi? Phi is the same phi that whatever you have studied in case of the cylindrical coordinate system, that is the angle with respect to the x axis. That is the phi. That is the phi. Okay, that means I can also write here it is the phi is equal to 0 degree, and also it is the phi is equal to 90 degree. Okay, and this phi is increasing in this direction. In this direction, phi is increasing. Okay, phi is increasing. Now, let me take a different color. What can I take? I can take this. Okay. Now, see, the point P is in the three-dimensional vector space. As the point P is in the three-dimensional vector space, this is not like a normal point. It is a vector point or the point vector. Now, as it is in the three-dimensional vector space and it is also the point vector, it must have the three components or the three directions along in the direction of r theta phi. It must have the three directions because I am talking about the r theta phi coordinate system, not the xyz coordinate system. As I am talking about the r theta phi coordinate system, so the point P is, as the point P is a vector point, it must have the three components along the direction of r theta and phi. So let us see what are those three directions or the three unit vectors. Now the first unit vector is along this direction, along the same direction of this r. Okay, along the same direction of this r. So that's why this is the, I can say this is the A of r, because this is the in the same direction of r. This is the r, right? You can see this is the r along the same direction of the r. So that's why I can say this is the r direction. Similarly, what is the theta direction? For theta direction, look at this. Theta direction is actually, theta is increasing from z equal to 0 or the z axis toward this xy plane. Theta is increasing from the z axis towards this xy plane. That is, at z axis theta equal to 0, then at xy plane theta equal to actually 90 degree. Okay, so that means I can write the theta direction, show the theta directions like this. Okay, I can show the theta direction like this. So that means I can write this is the a theta. Okay, this is the a theta. Similarly, I can write the phi direction. Phi direction is same as I have already discussed in case of the cylindrical coordinate system. It is the phi direction. Phi direction is same. That is the in the same direction of the actual phi. The unit vector of the phi will be in the same direction of the actual phi. That is the phi will be like this. Okay. As this happens, as you can see, these three are orthogonal to each other. Okay, these are the orthogonal to each other. So that is nothing but there is a 90-degree angle in between them. Okay, that means they maintains the orthogonality. Now, some more things I want to mention in this diagram. Now listen to this portion very carefully because most of the misconception happens here, most of the difficulties occurs here. Now the portion whatever I am going to tell you. See this portion very carefully. I am trying to use some different color. Let me select which color I should use. Black. Okay, black. Let's use black. Now, as this length is r, right? This length is r. As this length is r, okay, that means this. Which length I am talking about? This is the length. This length I am talking about. Okay, this length is what? R. that has been shown over here. That is the R. Sorry, I will not overwrite here. Whatever the length is R. Now this is R and this is the angle theta. Now what will be this? This line. What will be this total line? What can I say? Let me show you like this. What will be this line? This is R. This is theta. So what will be this? This is nothing but the R sine theta, right? Now, most if you can't understand this portion how the R sine theta has occurred over here, don't worry. I am drawing a separate diagram for you guys, so don't be hesitate. Okay. So if this is R, for now just understand like this. If this is R, I will show this portion differently, and I will show each and every point whatever I am telling over here. Okay. So this is R and this is the theta. So I can write this is R sine theta. This is the basic trigonometry actually, and this can also be written as rho. Rho means in case of the cylindrical coordinate system, the same distance was rho, right? So if this is the R sine theta, can you say what is this? Just a minute. I have to draw arrow again. What is this? This is nothing but the R cos theta. This is nothing but the R cos theta. Like, let me remove the origin. The origin. Oh, no, no. This is the R cos theta, right? Okay. So this is R sin theta. This is R cos theta. Now, if you don't understand this point, now look into this diagram, whatever I am going to draw. How this R cos theta and R sin theta occurs. If you don't understand this, for those, I am writing a separate diagram. So I have to draw the coordinate system again. So give me some time for that. Okay. Now this is X, this is Y, and this one is Z. Okay. And this is the R. Oh. This is the point. It is the same point as P. Okay. And what is the R? R is the distance between the point P with the origin. Okay. It's the R. It is the R. And what is the theta? This theta. And this is phi. This is theta, this is phi. Now tell me, according to the trigonometry rule, if this is theta, I can also write, just a minute. If this is theta, I can also write this is also theta. This is r, this is theta, then what will be this? This length. This length will be, this will be what? R sine theta. And that is the same rho, whatever you have seen in case of the cylindrical coordinate system. Okay. Now, again, this is r, this is theta. What will be the base? This is the height. Height is nothing but r sine theta, and base is what? Base is nothing but the r cos theta. R cos theta, right? Okay, this is the r cos theta. R cos theta, r sine theta. Now, this is also r sine theta, right? Because these two are the parallel line, right? I think now you have understood why this r sine theta equal to r cos theta has been written over here, and the r sine theta equal to rho has been written over here. Okay, this is the same portion that I have written over here. This portion. Okay. Now, I think you have understood all these points very carefully. Now, let us give you the definitions of the rho, r theta and phi. Just like as we have given in case of the cylindrical coordinate system, we have shown how rho, phi and z, what is the range of the rho, phi and z, etc. In the similar way, I will show you what is the r theta phi actually, or the definition of the r theta phi, as well as the ranges of the r theta phi. Okay. Now the first one is the r. What is the r? First point about the r is, what is r? I have already told you what is r. R is nothing but the distance between the point P, C. Here you can also see there is the distance of point P with respect to the origin, because this is what? This is the origin. Okay. So this is the point P with respect to the origin. In the main diagram, you can also see that this is the green color line, that is the R actually. This is the distance between the origin and the point P. That's what I will write here. That is nothing but the distance between distance of point P from origin. Distance of point P from origin. Okay. Now, what is the range of this R? The range of this R is, what is the range of this R? It is starting from the origin. That's why that is the 0. Okay. That is 0. And it can go up to what? Go up to infinity. Right. That is the radius, infinite radius circle, or the sphere of the infinite radius. It may happen. Now look at this point. Don't tell me that, sir, you have done a mistake, you have done a parenthesis over here and you have done a bracket over here. Not like that. See, the r equal to 0 value is included in the line. Okay. But the r equal to infinite value is excluded. Okay. I think you have understood this point, because you cannot assign the infinite, or you cannot assign r is equal to infinite, because infinite is not a fixed value. So that's why I have given a parenthesis over here. It is a engineering mathematics concept. I think you have learned it. Okay. Now, what is the theta? I have given the definition of the R. Now, what is the theta? Okay, for theta phi, I will do a thing. I need some space for theta and phi. What is the theta? Now, theta is also called as a elevation angle, because if you see this portion carefully, this portion carefully. Now, theta is an angle depending upon which the P is varying vertically, right? That means theta is an angle uh, depending upon which P is varying from the z axis to xy plane. Means it is an elevation angle, just like as a elevator of aeroplane. I think you know what is the elevator of the aeroplane. The elevator of aeroplane varies vertically, right? So that's why as the theta is also varying vertically, that means in these directions. I am also showing you what is the elevator. Two things you have to understand: elevator and azimuth of aeroplane. Let me draw the tail of aeroplane. Tail of aeroplane looks like this, and now what is the azimuth and what is the elevation? See, these two are called elevator. Why? Because if you see, these two things are varying, or these two things are stimulated in the upward and downward direction. Okay, that is called the elevation. This is called actually the elevation. Just a minute. These two things, depending upon the plane, rises up and down. Okay, these two things. So that's why these two things are called the elevator. And these things, that is also called the radar. Okay. This is called the azimuth. Okay, this is called the azimuth. Also, in case of the aeroplane, it is called the radar, which is used to direct it the plane left or right. Okay. Whether an aeroplane aircraft go left or right, that is decided by this radar, and whether the plane will go up or down. I'm sorry. Just a minute. Whether the plane will go up or down, that is decided by this elevator. Okay, this is the up and this is the down, and this is the left or this is the right. Okay, that is the concept of the azimuth and elevation. Okay, now it will be easy to understand what is the theta and phi angle. Theta is called the azimuth angle. Why we call it as a azimuth angle? I think it will be easy to understand for you. It is the concept of Okay, right? That is the concept of the azimuth elevation. Just a minute. Let me write it correctly. Now the theta angle. What is the theta angle? Theta angle is varying like this elevator. So that's why this theta angle is called the elevation angle. Now what is the theta angle? That is the elevation angle. Now that's what I am writing over here. What is the angle actually? Definition, by definition I can say this is the angle made by the position vector with respect to the z axis. Right? This theta angle. This theta angle. This theta angle is made by this position vector p with respect to the z axis. Right? So that's what I am writing over here. So what is the theta angle? That is the angle made by position vector which has been denoted by the point P, right? Now, what is the range? This portion is very much important. What is the range of this? Now, range of this, I will write the range later on. Okay. But before that, let me discuss what is the phi. Now, the variation of the phi is like this radar of aeroplane. That is the azimuth. So that's why phi is called the azimuthal angle. Okay. Because you can see over here also that the angle phi is varying above the xy plane. Angle phi is varying above the xy plane. That means it is varying like a azimuth or the radar of aeroplane. So that's why this is called the azimuthal angle. Now, what is the actual definition of the phi? Now, what is the phi actually? This phi angle, see, this phi angle has been made above the xy plane or in the xy plane with respect to the x-axis, right? I can say, right, I can say it like this: the phi is the angle which has been made in the xy plane with respect to the x-axis, right? This x-axis. Theta is the angle that is made by this point or by this point vector p from the z-axis. So that's what the phi is. So phi is like phi, I can say that is the angle, okay, made in the xy plane, angle with respect to x-axis. What is the range? Okay, I will write this range later on. Now, range of theta and phi. See this point very carefully. Now in the three-dimensional vector space, this is another concept. So let me box it. The concept is about range. Fine. Oh, inside I have to write. Just a minute. That is the concept is about. Okay. So in the three-dimensional plane, that is in the XYZ, this is the XYZ. In the XYZ, okay. So this is the XYZ, this is the X, it is Y, and it is right. This is the X, Y, and Z. Now look at this carefully. In the XYZ coordinate system, I have to make a sphere. I have to make a sphere. Now to make a sphere, how we have to vary the angle theta and phi, or I can say that how you have to vary the azimuthal and the elevation angle, that is important. Ultimately, I have to make a sphere. Now for making a sphere, how you have to vary that angle theta and phi, or the elevation and azimuthal angle respectively. You have to vary these two angles together. Okay. Now what is the theta? Here theta is 0. Here phi is 0. Now theta is varying in this direction, right? Theta is varying in these directions. Here theta increases, and here also theta is equal to 90 degree, and here is phi also equal to 90 degree, and also the phi is varying in this direction where phi increases. Now how you have to vary this theta and phi so that I can make a total sphere. Now see, if I vary theta from 0 degree to this 0 degree to pi, if I vary like this is the theta equal to pi. If I vary like this, then it will form a semicircle. Now I am varying the theta from 0 degree to pi degree by fixing the phi at any particular angle. Say the phi is not varying, okay, or the phi is fixed at a 90 degree. Now at 90 degree, let's say the theta is varying from 0, from this 0 to this pi, okay. If I vary theta from 0 to pi, then it will form a semicircle. Like, and if I rotate this semicircle, if I rotate this semicircle for one complete revolution, I am rotating this semicircle for one complete revolution. That means I am varying. Now the theta is fixed. Okay, theta has been varied from 0 to pi. Now I am not varying theta right now. Now we rotate the this semicircle for one revolution, for one complete revolution. That means I have varied the phi from 0 degree to one complete revolution. That means the 0 degree to 2 pi degree, right? Like this. Means what happened actually? First of all, I have made a semicircle just by varying this theta equal to 0 degree and theta is equal to pi. By fixing a phi, a particular angle, let's say the phi is equal to 90 degree, I have fixed it. But by fixing the phi is equal to 90 degree, that is above the YZ plane. Okay. So by fixing the phi is equal to 90 degree, I have first varied theta from 0 degree to 2 pi, 0 degree to pi degree. That forms a semicircle. And if I rotate this semicircle depending upon the axis or the z axis or the center for one complete revolution in any direction, whatever you can direct, your direction is, that is the by the range of the phi 0 to 2 pi. Actually, one complete revolution means you are varying the phi from 0 degree to 2 pi, right? That means you have done a complete revolution. So I have just completely revoluted this semicircle. That means by varying the phi 0 degree to 2 pi. Okay, so that's what the range of the phi is. That range of the phi is 0 to 2 pi. And you can also remember the range of the phi was same that as of in case of the cylindrical coordinate system. The range of the phi is 0 to 2 pi. But what is the range of the theta? Remember the range of the theta. The range of the theta is nothing but 0 to pi, not the 2 pi. Here most of the students do the mistakes. They think that okay, a complete revolution has to be made, a sphere has to be formed. Okay, so the variation will be 0 to 2 pi. Not like that. The theta or the elevation angle will be varied from 0 to pi because we have to make a semicircle. After that, we have to revolute the semicircle for one complete revolution. Means we have to vary the phi from 0 degree to 360 degree. That means 0 degree to 2 pi. Okay, that is the range of the theta and phi. Okay, right? So I think you have understood this point very carefully. Now the note, I have to make a note over here. What is the note about? You know this note very much. That is, just a minute. Let me write a note. What is this note about? This note is about the unit vector of r, theta, and phi. You have already seen here that the unit vector, that is the direction of the r, theta, phi, are orthogonal to each other. You know that. I have already discussed it about here, and in my last two or three videos, I have discussed about rho phi z and the xyz unit vectors also, right? The unit vectors of this r theta phi or the spherical coordinate system are orthogonal to each other because each of the unit vectors produces the angle of the 90 degree with another, right? So that is the note I am writing over here. That is nothing but the unit vector of AR is perpendicular with respect to the unit vector of the A theta, is perpendicular with respect to the unit vector of A phi. Okay. That means the unit vector are perpendicular to each other means AR, A theta and Phi are orthogonal. Right? Means they obeys RH-Carl rule. Now the orthogonality concept has been produced by what? RH-Carl rule. So that means they obeys the RH-Carl rule. Now what the RH-Carl rule says? So I can write that is nothing but the AR cross A theta. That will be what? Phi. Similarly, A theta cross A phi will be AR, and also A phi cross AR will be A theta. Now remember that if you interchange these two things, that is A theta cross AR, that will be what? Minus Phi. Now this is the cross product of the vector. So interchanging the values of the elements or interchanging the elements in case of the cross products produces the negative Phi. Okay. Also Phi cross A theta will be what? Not the AR, it will be the minus AR. And also the AR cross Phi, that is nothing but the minus A theta. Okay. Okay. So the right hand Carl rule. According to the right hand Carl rule, we can conclude about it. Okay. So that is the basics of the spherical coordinate system. In the next video, we will discuss about the differential length, area, and the volume concept in case of the spherical coordinate system. Okay, that is also very much crucial and very much conceptual. Okay, so whatever I have studied, I have taught till now, you have to revise each and everything so that it will be easy to understand that portion of the differential length, area, and the volume concept in case of the spherical coordinate system. Okay, so that's all about it, and in my next video I will meet you soon. Thanks for watching.